Hey guys, it's Miss Gregory. I'm making a supplemental video for lesson 8.3, Functions, Tables, and Graphs. This goes with example 2 on page 597. You will need your workbook, you need notebook paper, and you need a pencil, and you need your focus. Remember, this is not in the book. This is an additional video to help explain what was not in the book. Okay, here is a picture of breaking down what you need to know at this point. You have the function table listed here with the input, which is also called your x, the output, which is also called your y. Okay? Now, a function can be represented by a graph, it can be represented by a function table, it can be represented in words, it can be represented by an equation. Now, this table has been filled in for you, and the inputs here were chosen of 1, 2, and 3. When you use the function rule above, y equals x plus 2. That means you're going to add 2 to the input. So in this case, you would say y equals x plus 2. If x is 1, then you would say 1 plus 2 is 3, and you can see that's what they put in their output column. So they went through, did everything to complete the table, and you see they have an ordered pair over here that we talked about in class today. Your ordered pair is x, which is the input, and y, which is the output. With them together, you can then move over here and plot the points on your graph by crawling across and walking up. You can see that they've labeled all their points, 1 and 3, 2 and 4, and 3 and 5. When you draw a line through the points, and you can see in this case that when you connect the dots you make a straight line, you are verifying that it is a linear function with the word line in it to remind you that if it makes a straight line, it's linear. Okay, doing an example from scratch is what the book is lacking. So I've whited out some of the information. So looking at example 1, graphing a function, all they give you is that you need to graph this function, okay? And from that, they need you to go way down here. But you can't do all of that in just one big step, okay? So what we're going to do is make an input-output table. They already have the shell for you, which we talked about in class. You have your input column here. You have your function rule here that you're going to substitute and solve for. You have, once you substitute and solve, you have your output column, and then of course here you have your ordered pair column, your x's and your y's, which you can now go and graph. So in the directions it says make an input-output table, and it tells you what values to use, 1, 2, and 3 for x. Now, I mentioned in class you can choose any numbers you want. I typically choose 0, 1, and 2 because to me they are definitely the easiest, but 1, 2, and 3 will also work. So we're going to go through here and put 1 and plug this in. So if x is 1, then I'm going to have 2, substitute 1, plus 1. So I have 2 times 1 is 2, 2 plus 1 is 3. So the y is 3. So my ordered pair is 1, and 3. Okay, so next I'm going to substitute the number 2 for x. 2 times 2 is 4. 4 plus 1 is 5. And so my new ordered pair is 2, 5. And last I'm going to plug in a 3. I've got 3 times 2 is 6. 6 plus 1 is 7. And my last ordered pair is 3, 7. Now I mentioned in class you need at least 3 points in order to graph and make sure that the graph is linear or not. You need 3 to decide if it's moving in a straight line. If you do more because you're unsure, that's up to you. That's optional, but you have to have at least 3. Okay. Now, let me go over here. And clear the slide. Okay, you can see that the points have been plotted from here. The ordered pairs that we plugged in are here, crawling across 1 and up to 3, crawling across 2 and up to 5, and crawling across 3 and up to 7. Then all they've done is extended the line, connected the dots, and one more thing they will be asking you is that if it makes a straight line, it is a linear function. Okay, so now we're going to work some of the examples below. Okay, we're going to work problem 2 off this page. The function rule they've given you is y equals 3x, written as an equation. I set up a table and I added a little graph that we can work with. So you're always going to have your x input column. Leave a column in the middle for your function rule. In this case, the function is y equals 3x. And then you have your output. So input, rule, output. Then you have your x, y that you're going to take over to your graph, and you're going to plot those pairs. So I'm going to choose for my outputs to be 0, 1, and 2 so you can see how easy they are. Okay, so I have 3 times 0 is 0. I have 3 times 1. Notice I'm just substituting, plugging it in, and getting the output. I have 3 times 2, and that would give me 6. It's an easy, simple rule. It's easy to understand. So the ordered pairs that I need to plot on my graph are 0, 0, 1, and 3, 2, and 6. And I mentioned that you could even make another column here with your XY ordered pair. That's up to you. Alright, I'm going to change colors. And remember, this is your y-axis and this is your x-axis. We're always going to move across, crawl across first, and then walk up. Okay? So this little corner right here is called the origin. It's 0, 0. I'm going to try doing this with my finger because the stylus doesn't work very well. So hopefully you can see the little purple dot there for 0, 0. Now I'm going to walk over 1, and I'm going to go up to 1, 2, 3. Okay? Notice that's 1, that's 2, and that's 3. Alright, so there's my next point, 1, 3. Then I'm going to, again, crawl across to 2, and I'm going to walk up to, there's 3, 4, 5, and 6. Kind of hard to pinpoint that. Sorry, it's not supposed to be 2, but one big dot. And this would be 6. Okay. Trying to fix that, but it just doesn't work with the stylus very well. So I'm going to change colors here and show you that if you connect the dots, That line is continuous. It does form a straight line, so it would be a linear equation, a linear function. Okay? You have completed what you need for the directions, which says to graph the function, which you have to do by completing the function table, adding your own inputs, substituting the rule, getting your output, then you take your points and you plot it. Okay, so here's a quick rundown of the steps you need in order to graph a function. First, make the function table, the inputs column, the output column. Second, you need to choose 3 inputs. Choose something easy. Number 3, you need to Okay, we have question number 4 from your homework tonight on page 599. This is assigned homework question number 4. 2x plus 5/10, a half. Okay, written as a decimal. So it's going to be up to you whether you want to still use 0, 1, 2, 1, 2, 3, or whether it would be easier for you to choose something with decimals to substitute so that when you go to write it on your graph, you have a number that fits exactly on the 1, 2, 3, 4 lines, or if you want to have something in between. All right, let's try 0 and see what we get. When I choose, I've already made the table. This is the same thing that you would do. I just, to save time, went ahead and drew it. So you have 0. Plug that in. 2 times 0 plus a half. Okay, 0 times anything is 0, so my answer is just 5/10. Okay, so you could go over here to your graph and start at 0 and go up to 1/2, which would be about right there. It's not exact, but it's pretty close. It's what you call eyeballing it. Okay, that works. Let's try 1. 2 times 1 plus a half. Okay. 2 times 1 is 2. 2 plus a half is 2.5. Alright, so I'm going to go over 1 and I'm going to walk up not just to 2, but 2.5, so about right there. Next I'm going to try x is 2, plug it in, 2 times 2 plus a half. So I've got 4.5. So I'm going to crawl over 2 and go up to 4.5. And again, sorry the points aren't working exactly how they should with the stylus. But what you can see is even with having the decimals, my answers didn't turn out too messy and I can still graph them because it's a halfway point. That to me would be easier than changing your inputs to accommodate the decimal. Now the last thing that you should do is connect the dots, end with an arrow because this line is continuous and it keeps going. And since it makes a straight line, then you would also say that it is a linear function. Okay, we're just getting ready for tomorrow's lesson, which is adding that one more step. So graphing the equation, homework question number 4, they give you the equation, you plug it into your input-output table, your function table, you choose the inputs, you substitute and solve, you get the output. You've got an x and a y coordinate, you've got 0.5, you've got 1, 2.5, and then your last thing to plot is 2 and 4.5. And you can see that they do make a straight line. Alright, thanks guys. We'll see you in class tomorrow. This was your supplemental video of lesson 8.3 with one of the homework questions number 4 worked out for you. Have a great night.